Hi everybody, welcome back. In this video, we're going to continue our discussion of the Lumen method, but we'll be adding some different factors to make our calculations a little bit more realistic. So let's remember that the Lumen method is used to determine the average illuminance in a room, and therefore we tend to use it for ambient lighting. Illuminance is going to be defined as lumens divided by area. But there's a big caveat with this equation. It assumes that all of the lumens emitted by a lamp, by a luminaire, will make it to the floor or to the work plane of a space. That's not actually true. So when using the Lumen method, we make our calculations more realistic by including two factors. It's the light loss factor, or LLF, and the coefficient of utilization, CU. All right, so the light loss factor accounts for the fact that not all lamps produce the rated amount of lumens, and it tends to fall off over time, and therefore we actually design for how we want the system to perform later on down the road and not initially. All right. The coefficient of utilization takes into account the fact that not all the lumens produced by a lamp actually make it to the work surface. They bounce around the room, all right, and they might be absorbed by some of the different surfaces. This factor takes into account the layout and the geometry of the room that your luminaire is in. So, as we've defined illuminance as the light that actually makes it to a surface divided by the area of the surface, all right, E equals the lumens times the light loss factor times the coefficient of utilization, all divided by the area. All right, and you'll see this in your textbook on page 179 right here. It's the basic formula for determining the average illuminance on a work surface. Let's talk a little bit more in detail about that light loss factor. Not all lamps are going to produce the rated amount of lumens. Light output actually decreases over time, and it can be as much as 25% over the life of the lamp. So the LLF is a multiplier that we use in our calculations to account for the future decrease in performance. And here's some graphs to show you. Let's take a look at the left one. If we have a design with a target illuminance, all right, we want this amount of light in the room, all right, and we design to meet that illuminance right at the beginning of our design's life. All right, then as the light level declines over time near the end of life, our room, our space is actually going to be underlit. So what we do is use this LLF to increase our goal illuminance. All right, so that as it decreases over time, we will eventually meet. We will never dip below that target illuminance. Now, the problem with this, of course, is that you can get glare and overlighting at the beginning of your lifespan, and that's a big reason that you want to use dimming controls and other ways to reduce overlighting. Now you can dig even deeper and take a look at the different factors involved in the light loss factor. All right, they're separated into two categories: recoverable and non-recoverable. Recoverable ones are ones that you can fix out in the field. All right, some maintenance person can fix that. Non-recoverable are ones that are really built into the system and they don't change over time. All right, and the two that you might that are the biggest and affect this the most are called LLD, or lamp lumen depreciation. All right, that's the loss of lumens simply due to the design of a lamp, and luminaire dirt depreciation. Okay, loss of lumens due to dirt and dust accumulation. right, that we can fix simply by cleaning the lamp. So how do we calculate the light loss factor? All right, you can calculate that. All right, and there is all of those different factors that we just saw. You can use a shortcut calculation that only uses the lamp lumen depreciation and the, what is the other one called? Luminaire dirt depreciation factors. All right, you multiply those, you get the light loss factor. All right, and that's the path that your textbook walks you through, and you'll see that in figure 8.6, table 8.1, 8.2. In general, you can also use an industry standard generic value of light loss factor 0.85. So what does that light loss factor mean? It means that our calculations are going to expect that only 85% of the light that we produce is going to reach the room's surfaces. All right. And so we need to include that in our calculations so that we design not for how we want our system to perform day one, but for it to perform a couple of years down the road. So take a look at our illuminance uh, formulas, and you can see the light loss factor included here. Thanks, everyone. In this video, we talked about some of the ways to make our illuminance calculations more realistic within that lumen method and focused in on the LLF, or the light loss factor.